Let me know when I can start.
We just started, Francesca. Good morning, good afternoon, good evening, and welcome at the next session of the Global AI Community on Virtual Tour. I am Sami, and together with Alicia, and now we would like to invite a new speaker, Francesca Lazzeri. Hi, Francesca, welcome at our virtual conference. Could you
Hi.
introduce yourself to us?
Of course. So first of all, thank you so much for inviting me. Thank you, Sami and Alicia, for hosting this session. My name is Francesca Lazzeri. I work at Microsoft. I'm a senior cloud advocate lead, and I lead a team of cloud advocates, and specifically we focus on AI and machine learning. And today I'm here to talk about how you can train and operationalize, meaning deploy your machine learning models, and at the same time, how you can understand your machine learning models, why they are producing specific types of results. That's why I'm calling these interpretable machine learning models. The agenda for today, for this session, is pretty straightforward. I really want to focus on three main components. These are, as you can see, I really want you to learn how you can select the right tools to succeed with your model deployment, how you can use automated machine learning in order to accelerate your machine learning workflow, and finally, how you can use modern interpretability toolkits to understand better what your machine learning models are doing. So I call these the three components of model operationalization, which in my opinion are extremely important because as a data scientist, I think that building beautiful models, very accurate models is extremely important, but then we don't have to forget the following step that is about operationalize your model, is about making sure that your model can be consumed by other people in your company or within or from other companies external from your organization. So this is actually the real power of machine learning and AI. So how can we select the right tools to succeed with model deployment? First of all, let's think about what's really machine learning. I remember when I was still studying, one professor said, you know, machine learning is about extracting knowledge, insights from data. And this is true. Like the core part of machine learning is really using data to build intelligent applications that are going somehow to help you with improving a specific process, solving a business problem, and so on. But really, when you work as a data scientist or as a data engineer, what you do is the following. So there are three different steps. The first one is about data preparation, as you know, that is a very tedious and long process. The second one is about experiment. This is what it really means. It really means that first of all, you have to build your model. And right now, I think that we are very lucky as a data scientist because you can pick like a different IDE in terms of what you prefer, like Jupyter, Visual Studio Code. Then you can train and test your model. Finally, you can register and manage your model, and you can, the third phase is about then deployment. So you can build an image and deploy your service as deploy your model as a web service. And all of these, of course, is not just a one-time process. It's actually what I call an orchestration type of process. So it's very iterative, and you have somehow to go back and forth and make sure that your end-to-end process, your end-to-end solution is actually working well. And if you can, you need to automate these. That's why now we are thinking a lot about DevOps for machine learning, and is actually called MLOps. MLOps is really a way to automate your end-to-end machine learning solution. specifically the deployment process, and is also a way, as a tool to build what I call transparent and interpretable AI, meaning that if you use MLOps as a tool, but of course you use also additional tools that we're going to see together today, such as automated machine learning or model interpretability, you can really build a strong end-to-end machine learning solution, and you can deploy it. Why is so important, and I think that MLOps can really change the way that we do machine learning and AI. So, as you know, as probably you know, you work in data science and AI, there are many different pain points when you work as a data scientist. Some of these are the fact that data scientists do not speak the same language as software engineers. So most of the time we work in silos, and MLOps can help us in actually solving this problem. Scripts most of the time are stored on one person's machine, and the process is not repeatable. So this is another very, very big challenge. There is also a model versioning that is based on different names, so it's hard to know where the model is deployed. And sometimes these names are really, I would say, customized, so it's also sometimes difficult to remember these type of models. Then the accuracy of the model is determined during training and might change over time because of the data drift, as you know. So sometimes we can think that retraining your machine learning solution can help, but probably not always. Finally, the last challenge is that you have to determine the value of the trained model and decide if it should be deployed or no. So this is again another challenge, because of course you want to always try to deploy the best model, but sometimes the best model in terms of accuracy is probably not the best model in terms of end-to-end performance. So it's another important challenge that data scientists and software engineers have to deal with every time that they build end-to-end machine learning solution. So MLOps somehow solve this because it really provides a consistent way to discover, store, and track and share models. It provides a consistent model metadata format, which is also important, and we're going to see this a little bit together during the demo. It also helps a lot with tracking where a model came from, which data, which experiment, previous models, where the code, the notebook is. Finally, it tracks where the model is running, and also if the model is what we call healthy model, and also has control and access to what model. So this is you can actually define this type of control and access. So there is in the case that you have a private type of data. It's important to also understand that MLOps besides offering all these advantages, so besides solving some of the challenges that I was mentioning in my previous life, is also very important to improve the management of your model lifecycle. Why? Because when you use MLOps, you can track model versions and metadata with a centralized model registry. You can leverage containers to capture runtime dependencies for inference. You can leverage an orchestrator, like for example Kubernetes, to provide a scalable inference. And you can also capture the model telemetry. These are very important if you want to monitor like the health, the performance, the inputs and outputs. Finally, it's also important for the two main things. Actually, these are very, very important. Is able to somehow encapsulate each step in the lifecycle to enable all DevOps. So this is also important, and automatically optimize models to take advantage of the hardware acceleration. So you don't have really to think too much about also optimization and performance type of problems. So MLOps, as I said, somehow is a term that we got from DevOps. So DevOps is all about code reproducibility, code testing, app deployment, and MLOps is still about the same things, more or less. It's about model reproducibility, which is extremely important. It's about model validation, model deployment, and model retraining. That's why it's a very important component. And when I try to teach other data scientists how they can build a end-to-end solution, I always say that one of the components that they should look at is how they can leverage, exploit MLOps for their end-to-end machine learning solution. So in practice, how this really works. So most of the time, data scientists are working with a team of different engineers, developers, data engineers as well. So the good thing is that the first goal for data scientists is about model reproducibility. So how they can do this is important to have an environment that they can use to somehow look at and monitor the different versions of a code, data set, and the environment itself. Then, of course, in terms of the train the model and the validation of the model, they need somehow a tool that helps them with the model validation and the profiling. So this is also important. The third step is about model deployment. So here is about how they can package the model and how they can make sure that these deployment is actually good, is going to be a good experience across a cloud and edge. So you want to make sure that that type of experience, the deployment experience, is smoother both on the cloud and on the edge. Finally, in terms of model retraining, it's important to have some tools that are going to help you to, in terms of managing your model, monitoring your model, and then, of course, if you want to retrain your model, in case you want also to run a model performance type of analysis. So again, this is something that you can have right now is an extension for Azure DevOps. Azure Machine Learning actually has these extensions that we call MLOps, and is really a way of building your solution and make sure that you can deploy it, and also make sure that this deployment process is automated over time. In terms of code, so how can you actually deploy your model? So right now, in this part, I'm going to share with you some code examples, and then in the demo that I'm going to run at the end of this presentation, I'm going actually to use a different data set. But usually I like to share my code example with a very, very simple data set. As you can see, we are using for this tutorial a simple logistic regression using a Nest data set and the scikit-learn. So this is a very, very popular and famous data set. I don't have to share too many information about this because I'm sure that every data scientist knows this data set very well. But again, here the goal is about understanding what are the different pieces of code that you need in order to build your end-to-end machine learning solution. We're going to use the Python SDK. So it's a Python-based type of version, for the demo that I'm going to share later, actually we're going to use a little bit more sophisticated use case. Is a hardware performance dataset, and we're going to use not only MLOps, but I'm going to show you how you can use automated machine learning and also the model interpretability toolkit. So what is nice of the final demo is that it's actually showing you all the three pieces together. I'm going to share with you also the demo itself at the end of this presentation, so feel free to try that by yourself and let me know if you have any questions, feedback. And for the demo, we're going to learn together how you can create an experiment in an existing workspace, or you can also, you're going to see also there is the code actually to build, to create a new workspace, how you can initiate an AutoML config file with also the featureization capability to look at the different features and actually build additional variables on top of your raw data, how you can train the model using a remote compute, and finally, as I mentioned before, how you can explore the results and the featureization for transparency. So this is again what I call the model interpretability. But first, let's focus on the code itself. So first of all, the first things that you have to do in Azure Machine Learning, of course, is about creating your workspace. The workspace is really a place, is an environment that you can use to develop your experiments, or also to collaborate with other engineers, with other developers, data scientists. So once you have created this workspace, and again, you can create this workspace just specifying your subscription ID, if you want to give a name, a resource group, and a location. Then the second step is about creating your experiment. So the experiment is really a way to track the runs in your workspace, because a workspace, of course, can have multiple experiments. So usually data scientists really like to build, I would say, many, I don't want to share a number, but many experiments. So in a workspace, of course, is a sort of library, is your collection of machine learning experiment. After this, the third step is about creating a remote compute target. So first of all, as you can see in this sample notebook, you can choose a name for your cluster, and you can also specify the min and max nodes. As you can see here, 0, I just wanted to show you that the 0 is a default. So if min is 0, then your cluster is automatically deleted when no jobs are running on it. So this is a specification that is important to keep in mind. In this specific example, we are using a CPU VM, CPU virtual machine. And so you can just set the SQE to standard NC6. But again, we're going to see also in the other demo that you can also select different type of CPU, GPUs, and VM typologies. Then after that, you need to create a cluster. And after create a cluster, then you can poll for a minimum number of nodes and for a specific timeout. So again, this is also important, because if you don't provide a minimum number of nodes, then it will use the scale settings for the cluster. So this is another thing to keep in mind. Step 4, of course, you're doing machine learning, you need to use your data. So the fourth step is about uploading the data, your data to the cloud. I usually suggest first to load the compressed file into an NumPy arrays. You can use the load data. This is a custom function that simply parses the compressed file into NumPy arrays. So you can use that function. And then after that, in this case, as you can see, we are using the nest dataset. After that, you can make the data accessible remotely by uploading that data from your local machine into Azure, like Azure Blob, so that it can be accessed also for remote training or for other people in your team. So in this case, we are uploading the data into a directory that is named nest, that is at the root of the data store itself, as you can see from this sample. So now this is again everything that we need just for the training part of your machine learning model. The other steps are actually going to be about training the model itself. In this sample code, we are training a local model. And as I mentioned at the beginning of this part, in this case, we are training a simple logistic regression, and we are going to use a scikit-learn locally. And this, again, usually is taking just 1 minute or 2. That's why I think it's a perfect example to learn just about the different steps that you need to follow. And then after this, the other two steps that are important are 6, that is about training the model on a remote cluster. So step 5, as you can see, we train the model itself locally, but most of the time, of course, data scientists want to train their model on a remote cluster. So in this case, what you need to do is you need to submit a training job to a remote. You have to perform the following task. First of all, and this sounds a little bit more complicated steps, but stay with me, it's actually not really complicated, because these are things that I'm sure you have to do every time that you are using a remote cluster. Like, for example, the first one is create a directory. The second step under the step 6 is creating a training script. Then you can create an estimator object, and finally you can submit the job. So step 6.1, as I said, is about to create this directory. This is important because you want to deliver the required code from your computer to the remote resource. Then the other step is about creating a training script. So here is really about loading the train and the test set. In this case, we are loading them into 2 NumPy arrays. And then also we are using the data folder variable that holds the location of the data file itself. In this case, is from a data store. Finally, we get hold of the current run. This is what you can do with this run. And here, in the last part of this slide, is really when where the magic is happening. So this is really the machine learning part, because we are training a logistic regression model with a regularization rate that is of reg. So in this case, as you can see here, and as you can see, we are then using the fit function with the X-train and Y-train data sets. Then, as you remember, you have to create a training script. In this case, you can, first of all, calculate accuracy on this prediction. And after that you have done this, it's important to know that the training script saves the model into a directory that is named outputs in this case. And as you can see, is a pickle file. So all the files saved in this folder are actually uploaded, are actually automatically uploaded into this experiment record. So this is a pickle file. So anything that is written in this directory is automatically uploaded into the workspace. And this is something very important, because you don't have to think about the different parts, but it's actually something that is a store for you, and everything is again automatically uploaded into your workspace, which is, I have to say, very, very nice. Then if you remember, I also mentioned that it's important to create an estimator. Why? Because an estimator object is used to submit the run. So here, as you can see, I just show you how you can create this estimator. So there are different pieces. I just tried to make this as easier as possible to understand. So there is the S part. This is the name of the estimator. You can pick any name that you prefer. Then in this case, as you can see, the source directory, this is the directory that contains the script. So all the files in this directory are actually uploaded into the cluster nodes for execution. Then there is the script parameters. These are the parameters that are required from the training script. Then there is the compute target. This is the computer target. In this case, we are using the batch AI, but you can use other computer targets if you are more comfortable with. And then the training script name, of course, this is the name of the file, the name of the file that you use for the training script, and finally the Conda packages. So these are the different Python packages that are needed for this training. Now you're ready to submit the job to the cluster for the real training. So after this, you remember that okay, you have created this estimator, but what actually happened after that you submitted this job? So there are 4 different steps. These are image creation. So this is important because in this moment, a Docker image is created that is matching the Python environment specified by the estimator. In this case, the image is uploaded to the workspace, and image creation usually can take about 5 minutes, I would say. Then the scaling. So if the remote cluster requires more nodes to execute to execute the run that currently are available, it's important that you actually let them to add additional nodes. So this is done automatically, and again, it usually takes about 5 minutes. Running, so in this stage, the necessary scripts and files are sent to the computer target, and then the data stores are copied to the entry script, and then the entry script is run. And finally, there is a post-processing. So this is the directory that is called outputs, and here it's actually copied over the run history in your workspace itself so that you can access these results. So after this long step 6, there is a step 7, and we are about at the end, because after that you actually train your model. The other thing that you need to do is monitor a run. So here is the moment in which you really want to watch the progress of the run with the Jupyter widget. What is nice of the widget is that allows you to look at your monitor at your run, sorry, and allows you to monitor your run every 10-15 seconds until the job completes. So these are updates that the widgets can give you. I usually always use widgets. For example, here I put a snapshot of the widget that all shows you all the information related to that specific run. Like, for example, the status, if it is completed, the start time, or like, sorry, status can be completed, but can be, of course, so in progress or failed in case something went wrong, start time, duration, run ID, arguments, different regularization rates, accuracy, and so on. So as you can see, this is a very easy way to have an overview and to monitor each run of your machine learning pipeline. And then after that, you monitor a run, you of course want to see the results of your model. So once the model has completed the training, you can of course look at your results, your results, and in this case, you can just look at the metrics, which is something important. So in this case, you can use this function that displays the accuracy of the model, and you should see an output that looks like this one in case you are using exactly the same data set, the nest data set, and you are actually predicting the same variable that we are predicting right now. So this is again something that you should look at, but it's important to understand that okay, you want to see the results and you want to get the metrics of course of where your train model is after that your train model is actually done with running. After this, there is the probably final step. Almost, it's not really the final, but there is the register the model step. So here is important because you want to recall that the last step in the training script is about that pickle file that I was mentioning. So you have a scikit-learn nest model in this case, that there is a pickle file. And this is, again, is a store in a directory that is named outputs and is in the VM of the cluster where the job was executed for this. So the output, as I said, is a special directory that contains whole everything that is actually storing this pickle file, and this content appears in the run record in the experiment under your specific workspace, and the model file is also available now after that you finish to run your training piece is also available in your workspace. So you have actually a model file that you can access in your specific workspace. So you can register the model at this time. And after that you register it, the model is available to query, examine in case you want to run additional analysis, and finally to deploy it. So the deployment of the model, actually, it's the last step, but there are several smaller steps that is important to understand. These are four main steps. I try to simplify them as much as I could. So, and these steps are about creating the scoring script, creating an environment file, and then creating a configuration file, and finally deploying to ACI, that stands for Azure Container Instance. So in this case, creating the scoring script. So I would say that this is the most important part for the model deployment. As you can see, there are two functions. There is the init function and the run function. The init function typically loads the model into a global object, and this function is run only once the Docker container is started. And finally, there is the run function. So the run function use the model to predict a value based on the input data. So inputs and outputs to the run typically use a JSON for the serialization and deserialization of the model itself. But there are also other models and other formats that are supported and allowed for this. And after this, you have to create your environment file. So in this case, we are call it my-env file. This is a file that specifies all of the scripts package dependencies. So this is very important because let's say that you are using specific type of packages for your machine learning model, then you want, here is the moment that you want really to specify all those package dependencies. And in this case, if you specify those dependencies at this point, you make sure that all these dependencies are installed in the Docker image. In this case, as you can see, we are using the scikit-learn, as I mentioned also at the beginning, and we are using Azure ML, the SDK. Finally, you can create the configuration file. In this case, you are going to create the deployment configuration file, and you need to specify the number of CPUs and also a gigabyte for the RAM that are all needed for the IC container, because in this case, we're using IC container for the deployment. There are also some default values. As you can see here, we're using 1 core and 1 gigabyte for the RAM, for the memory. And so how you can now at this point deploy your model to a container, to ACI. So in this case, you can use different functions such as the configure the image. So in this case, you can use a build an image. Here you are actually building an image, then the scoring file. And in this case, you are specifying the scoring file, the environment file, and the model file. And then, can you also hear this? 1 second, please. I'm the only one who is hearing this noise in the background.
We don't hear any noise,
Okay,
Francesca.
so probably it's just me. Okay, sorry. Thank you for checking. So let me go back to my presentation. Okay. So Sorry for the break, but unfortunately my audio is not working very well. But, so let me go back to the slide where was here we are. I was explaining deploying the model to ACI. Okay, so so here is important just to remember that you have to configure the image. So as I was saying, you can use this function to build an image, and here you have to specify your scoring file, the environment file, and the model file itself. And finally, of course, you are about to deploy your model as a web service. So in this case, you have to register that image under the workspace, and then you have to send the image, in this case, to a Azure Container Instance container. So after this, I promise there is a last step that is about testing, of course, your deploy model. In this case, so you're done with the training, you're done with the testing, with the deployment, but of course you want to test the deployment model and how you're going to do this. In this case, you're going to do this by sending images to be classified to these specific endpoints. So the most important part here that I highlight, as you can see, is this function. So it's a request.post function that is actually the function that allows you to test your deploy models by sending these images to be classified, of course, as endpoints themselves. So so now that we got a better overview of what it means to build your model and to deploy it, let's understand how you can use also automated machine learning in this end-to-end solution. So automated machine learning is actually a very cool new capabilities that came to life to improve, I would say, data scientist life. Usually when you start building your model, you always start with the data set and then you focus on the model training. And there is what we call the manual approach to model training and to model selection and also to hyperparameter tuning. Of course, hyperparameter tuning is very important when you want to improve your models, makes your model even more accurate. So there are different steps usually that you need to focus on, such as a training algorithm. And then, of course, with this specific algorithm, you are going to identify specific hyperparameter values, and this is usually part of your first configuration. And then you go back, you look at different hyperparameter values to eventually improve your model, and you build a second model, and then you go back and you actually try different type of values, and then you build your third model. You go back and then you probably want to try a different type of algorithms, and you also wanted to see if doing some hyperparameter tuning on your second type of algorithm is going to improve your model. So you're going to actually do this. Now, in this slide, I just did it for 4 times, but you're actually going to build eventually many different models by testing different type of training algorithms and by doing a different type of upper parameter tuning and configuration. So as you can see, this process is actually very complex, tedious, it's very repetitive, and for data scientists is also very time consuming. So automated machine learning actually came into life to solve this problem of model selections and hyperparameters tuning. It's important because hyperparameters are adjustable parameters that somehow are able to improve your model health. It's important to choose those parameters before the training. Actually, there is no other way. Like, you have to choose those parameters before the training, and they have to stay constant during the training, also in order to evaluate the performance of your model itself. The model performance, as I said multiple times, depends a lot on this hyperparameter tuning process. So one of the challenges that data scientists actually have is about selecting these hyperparameters, because I have to say that there is no answer to this question: what are the best hyperparameters for my model? It's important just to go back, and the only way is to go back, try different hyperparameter combinations, look at the different results that your model is giving you, and then you can just go back and actually try to change those parameters, to try different values for them, and see how your model is improving. So it's very complex. Moreover, also picking the right machine learning algorithms, it's a very tedious and challenging process. The question to which algorithm I should use, I would say, is always it depends. It depends on the data that you're using. It depends on the accuracy that you are trying to reach. It depends also on the type of questions that you are trying to answer. So all these aspects are actually very difficult to keep in consideration. And when you are developing your machine learning solution, you don't have just to think about how I'm going to improve the parameters configuration for my machine learning model, but you also need to take into consideration additional aspects, such as, again, what are the different data sets that I can use, what are the different algorithms that I can use for my solution. Moreover, there are additional requirements that are also important to taking in consideration, such as the accuracy, the training time, the linearity, the number of different parameters that each different algorithm has, and the number of features that you're going to use for a specific program. So as I was saying, automated machine learning somehow simplify these, because he gives you a support for the hyperparameter tuning process. He offers you also different options in terms of optimization metrics. There is also a way to use a early termination in case you don't want to run the specific machine learning pipelines for too long. And then, of course, is also important because you can apply automated machine learning on your training script and your training data as well. So we're going to see later in the demo how you can actually implement automated machine learning. The only thing that I want to mention here is that it's nice that you can apply it to different models and learning domains. You can pick training frameworks of different choice, and you can also visualize all the configuration in one single place. There are right now 3 different tasks that are supported by automated machine learning. There is the classification, the regression, and the forecasting. In terms of frameworks, it's based on scikit-learn. The languages, of course, is for now based on Python. And in terms of the data types and data formats, for now is supporting numerical, text, and scikit-learn supported data formats such as NumPy and Pandas. Different data sources can be used with automated machine learning, such as local files and Azure Blob Storage. And then in terms of computer target, you can, of course, use automated hyperparameter tuning. In this case, you have different options, such as the Azure ML Compute, that is the Batch AI and Azure Databricks, and also the automated model selection. So this is local compute, Azure ML Compute, Batch AI again, and Azure Databricks as well. There are many different algorithms that are supported. Here I put just some of the classification and the regression ones. And also what is nice of automated machine learning is that the output itself, it's very, I would say, user-friendly. It's very interesting and to see how your model actually how different machine learning pipelines are performing. Like you can look at not only at the different iteration and pipelines, but also the different iteration metrics, best metrics, the different status, the duration, when they started, and so on. So the other thing that is important to remember is that automated machine learning is supported in Python SDK. So the demo that we're going to see together is actually based on the Python SDK. So it's you can just consume these using a Jupyter notebook and using Python itself. Finally, as you remember, there is the last part of this presentation that is about model interpretability. So model interpretability is actually a great addition to MLOps and the automated machine learning capabilities, because really it's a way for data scientists to understand what their models are doing specifically, and also to explain to different stakeholders, such as business decision makers, legal auditors, why they are getting specific type of results. What is interesting is that you can also look at the different global importance and local importance. Global visualization is like how you can understand the relation between the different variables and the target variable, and then the local importance and local visualization actually allows you to look at the actually the relation between data points. So why, for example, a specific customer ID was generated a specific output. So it's a very detailed and it's a very granular. There are different visualizations that you can use to get these explanations. And also what is nice is that there is what we call the featureization capability. That is a way to generate additional features on top of your raw data, and also understand what's the role of these features, which type of role these different features are playing in the accuracy of your model itself. So these are, again, it's a great capability to understand even better why your model, your machine learning model, is producing specific type of results. In terms of the different classes that are available through different and multiple SDK packages, such as the Azure ML Interpret one. This is the main package. This is containing different functionalities that are supported by Microsoft. There is also the Azure ML Contribute Interpret. This is a preview, and these are more experimental functionalities that, of course, you can try out. There is also the AutoML Explainer package. This is for understanding, exploring automated machine learning models. And then you can use the pip install Azure ML Interpret and pip install Azure ML Interpret Contribute for general use, in case you want to use the AutoML one, you can use the Azure ML Interpret Contribute. So this again, this is for AutoML used to get the interpretability packages. So I know that we are running a little bit out of time, so I'm going to be very, very quick on the demo side. And I'm going to share with you the notebook itself. So let's say that you can try this demo by yourself offline, and let me know if you have any questions. So this is the notebook that I built for you. In this notebook, what is nice is that we are, of course, as you remember, we are using a regression to evaluate the hardware performance, and we are using AutoML and also the interpretability package for explanation and the visualization process. So just quickly, what you're going to find here is the first part, of course, is the regular part just to set up your workspace and your experiment using, of course, your subscription ID and the specific resource group that you want to use. And after that, you set up your CPU in this case, but of course, you can also use a GPU. You're going to see how you can set up the training and the test data for your AutoML experiment. This is the snapshot of the data set that we are using for this specific experiment. The task, if you remember, these are the 3 tasks that are supported. And then after the customization part, the other thing that I want to show you is that here is actually running all the AutoML file that you created, and also for the transparency one, here you're going to see an updated featureization summary. So what are the different features that it was able to create for you? The nice thing is that after that you run the training part, you can also retrieve the model for explanation. So if you scroll down, what you're going to see is actually a dashboard that I want to show you. And here is the deploy of the web service itself. So after that you look at the visualization at the dashboard itself, this notebook is going to show you how you can deploy the service, so how you can deploy your machine learning model as a web service. So again, I just went very quickly through this notebook. Let me share with you all the resources so that you can test these by yourself. Some of the tools that we use today are all listed here. Such as MLOps and the GitHub repo, where you can find the notebook itself, and then all the other tools that we use, such as automated machine learning and Azure Machine Learning Service. You can find all of them here in this resource slide. So thank you very much. It was a pleasure, and I'm almost on time, 5 minutes late. Thank you.
Just on time. Thanks, Francesca.
Thank you.
So we did have a question about pricing. Is there special pricing for some of these or considerations for these AutoML features?
So this is a great question. The AutoML package itself doesn't have any price. However, in order to use it, you have to have, of course, an Azure subscription. And for the classification and the regression task, you just need the basic Azure subscription. However, if you want to use the forecasting capabilities with AutoML, you have to be on an enterprise subscription. But these are the only 2 requirements that you need. So again, just to make sure that we're all on the same page, you need to have already Azure subscription, and then you can access all the AutoML capabilities using the Python SDK. And the main difference between the forecasting capabilities and the regression and classification ones are just the type of subscription that you have, like if it is an enterprise SKU or a basic one.
Okay, thank you. And we are accepting additional comments in chat.globalai.community.
Sure.
And Francesca has her Twitter handle up, which is FR Lazzeri. So thank you for joining us tonight.
Thank you so much.
We appreciate that. Great session.
Thank you,
Francesca. Hope to have you soon again.
Yes. Talk to you soon. Thank you again.
Okay.
Bye-bye.
Bye.
Hey, my name's Akansha Malik and I'm from Melbourne.
Excellent, Sami. It's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉。
I'm Alpha Cassie from Australia. Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.